Okay, so today we are going to start discussing planes. Now, this plane is not your aeroplane's plane, it's a plane. What plane? Like we see a bread, and if we see at the top surface, it's plane. Okay, more examples like if we take out a single paper, and single paper is a plane. But the plane that we are going to refer today is the plane that is there in this space. And in this space, the plane is not limited. Like the dimension, this y dimension is not limited. Now it's going upwards and downwards in its own dimension. Similarly, the planes that we are going to discuss today, they are not limited. They're extending infinitely, but in their range only. This is a plane. Now, the boundaries of this plane are not limited. They are limitless. But the existence of this plane will only remain in this plane. I hope I'm making sense. So this plane, we are going to discuss about this plane. Now, how many different planes can be there? How there can be different planes? Planes can have different angles first. Okay, that's one thing. And planes can have different position with respect to the origin. These two different features are there with the plane. That is what we call as a plane, not the airplane's plane. So first, we are going to discuss about the plane's equation. So the general equation of the plane is ax plus by plus cz plus d. That is the general equation of planes. Let's discuss more and find out that how these planes are derived, how the equation of this plane are derived. So first we are going to discuss about the equation of a plane in normal form. Normal form means that we have a plane, and we know the perpendicular distance between the plane and the origin. Let me rotate it a little. We know the perpendicular distance between the plane and the origin. So this is the perpendicular distance in the origin and the plane. This is what we have, and this is equals to d. What else do we have? We have this perpendicular vector and its magnitude. So let me call this as this point as point P, and its dimensions as x1, y1, and z. Actually, we will not require them, so we can also ignore it. And instead of P, if we write N, that would be better. Why? Because we will know that this is a normal. This is a normal to the plane. And the distance is d. So this is what we have. And from here, we also know the ON vector. Okay, ON vector. We know its magnitude is D and its direction, let's call its unit vector is N vector, N cap. N cap is the perpendicular vector to the normal, to the plane. Now, N is the normal unit vector. So let N cap is Li. We are letting it Mj Nk cap. Element, because as we know, scalar components of unit vector are direction cosines. So element, ठीक है. Now, for finding out the equation of any curve, any plane, what we consider generally a general point, any point on the plane. So let me consider any point, and that point is having general coordinates x, y, and z. Let me draw the vectors here. So this vector OP is the general vector. Let me also draw another vector from P to N. From P to N. Now we have three vectors. Okay. ON vector is D N cap. OP vector being X I cap plus Y J cap plus Z K cap. Okay. PN will be is unknown to us. Is unknown to us. So let's apply the triangle law by on applying triangle law of vector addition. Triangle law of vector addition on triangle ON and P. So we know the arrows are going like this, and then this, and then this against. So the sum of these two, OP vector plus PN vector, should be equal to ON vector. OP vector is what? OP vector is OP vector. Let me write it like this only. Actually, yes, we can consider that OP vector is a general vector, na? So let's consider this vector as R vector. This is the general vector, R vector. PN vector is unknown to us. ON vector is actually D, which is its magnitude, and N cap, which is its unit vector. So from here, we can write that the PN vector is D N cap minus of R vector. Now, one thing that is very clear to us is that ON vector is perpendicular to Pn vector. And when two vectors are perpendicular, then we may say that their dot product will be 0. Okay. If that is so, ON vector is what? D n cap dot product with Pn vector, which is D n cap minus of R vector should be equals to 0. This is very important for us to understand. Let's bring it on the next page. Now, let's do the dot product. So dot product of a vector with its vector. So its magnitude square. It is because the angle between the same vector is 0. So cos 0 is 1. And magnitude becomes d square minus r into d n cap. Now, let me rewrite. See, r vector and n cap are the vectors. D is just the magnitude. Let me write d here. And r vector dot n cap is equals to 0. Let's bring this on to the right hand side. Now D cancels each other. So this becomes D is equals to R vector dot n cap. And this is our equation of plane. This is the equation of plane. Now recall, what is this R vector? R vector is general vector, which is xi cap plus yj cap plus zk cap. What is n cap? N cap is the unit vector of normal vector. Is the unit vector of normal vector. D is what? D is the distance. It is the normal distance of the given plane from origin. Okay, that's it. Simple. This is the equation of plane. Equation of plane in vector form. Now let's change it into the Cartesian form. How do we do? D is D. D is D only. R vector is xi cap plus yj cap plus nk cap. Dot product with Li, the n cap, which is m Li cap, mj cap, and k cap. So D equals to, now dot product. So we'll simply multiply the coefficient of I with I plus the coefficient of j with j. So xl plus ym plus n. Sorry, this is z here plus zn. This is the equation of plane. And now this might look bizarre to you because of I have written it. If you written it like this, Lx plus my sin z, then it's more familiar for us to remember. This is the equation of plane in Cartesian form. Remember, L, M, N are the direction cosines of normal vector to the plane and nothing. And yes, D. D is the normal distance. From origin. Now, from here, please remember this fact that if you are talking about a plane, we are talking about a plane. So its direction cosines or its direction ratios are same. Give me a minute. Are same as that of the normal vector given to us. Yeah. So what we are talking about, that dr, the direction ratios, the direction cosines will be the same as that of the given vector normal to the plane. Why? Because when we are talking about the plane do not have any direction. Like, let's say this plane do not have any direction. If we discuss about its direction like this, so it is also expanding itself in this direction, south, north, south, east, west, in all directions. So what will be wise to discuss about other than these directions? What will be wise to discuss about the perpendicular direction of the plane? Like this is fixed. This is fixed. So that's why we take this vector as the direction of plane. That is the reasoning behind it. Okay. So now one thing to note here, very important, is that, let me write in a new slide, that whenever in questions, if given normal vector, if the normal vector is given, the normal vector is given, then first check or make it a unit vector. Then only a unit vector, then only use it. Okay. Sometimes they will say that this vector is the normal vector to the plane, but you have to make sure that that vector's unit vector that you're talking about, unit vector is that vector whose magnitude is 1. And we know how to find it, unit vector divided by its magnitude. Okay, so let's now discuss an example. Discuss with the help of an example. The question says, find vector equation of plane. Find vector equation of plane which is at a distance of 6 by root 29 from the origin, and its normal vector from 0 is 2i cap minus 3j cap plus 4k cap. Interesting. So let's reread the question. We have to find the vector equation of the plane which is at a distance of 6 by 29. So D is 6 by root 29. Okay. From the origin. Okay, so the distance is given from the origin. Okay, nice. Its normal vector from origin is also given. So our normal vector is also given. 2i cap minus 3j cap plus 4k cap. Let's find out its magnitude to check whether this is unit vector or not. Square root of 2 square is 4, minus 3 square is 9, plus 4 square is 16. 16, 9, 25, 25 and 4, 29. No, it's not a unit vector. So its unit vector will be 2I cap minus 3j cap plus 4k cap divided by square root of 29. So that's a normal vector. Now we know what is the equation for a normal, for a plane when it's normal vector and the distance is given. Okay, this is the equation. So r vector, what is r vector? R vector is a general vector. So x. So if we have to find out it in the equation of uh, if we have to find the equation of plane in vector form now, so we do not have to write I cap j cap j k cap for r vector. We'll leave it at as r vector only. R vector dot n cap, which is 2I cap minus 3j cap plus 4k cap divided by square root of 29 is equals to d, which is 6 by square root of 29. Square root of 29, square root of 29 cancels, and the answer becomes, uh, wait a minute, file is saving. So the answer becomes r dot 2I cap minus 3j cap plus 4k cap is equals to 6. That is our answer, which is the equation, the plane in vector form. So this is how we utilized our concept that we have learned. Equation of plane in normal. Let's now discuss about the equation of plane in different circumstances when we have different things. Okay, so this time we are going to discuss about the equation of plane when it is perpendicular to a given vector. Given vector on the plane. On the plane. And passing through to a given vector and passing through a given vector. That is what we are going to discuss. Let me draw the plane and the diagram. And so this is the plane that we are going to discuss about. Let me draw it a little bigger. So what is given to us is the normal vector is given. Okay. So let me draw a normal vector. This is given. This is normal. And what is given? And there is a vector given on the plane. So let me this vector is given. So its point will also be known to us. Coordinates, basically the coefficients of the vector, and this vector is A. Let me uh, take any general point in the vector, any general point. Its coordinate as x, y, and z, which are the general coordinates, and this r vector. Okay, let me do another vector from A to P. Why from A to P only? Because we need to find out. You can also take it otherwise, but that's more conventional. Okay, so A vector is given, normal vector is given. These are the only two informations. Means we know a point on the plane and we know the normal vector to the plane. Okay. So first let's find out AP vector because we don't know about that. So we will do so by simply applying the triangle law on triangle OAP. So which says OA plus AP. Now this is against the flow. So OP vector is equals to OP. OA vector is actually A vector. AP vector is unknown to us. OP vector is actually R vector, general vector. So AP vector becomes R vector minus A vector. Cool. Now AP vector is a vector on the plane. So and the plane is perpendicular to the normal vector. Yes, plane is perpendicular to the given normal vector. And we know on plane there exists a vector. So AP vector will also be perpendicular to the normal vector to the plane. So hence we can write two normal vectors dot product will be 0. Correct. But now there is only calculation left. AP vector is R vector minus A vector. Okay, R vector minus A vector dot n equals to 0. Equals to 0. And this, ladies and gentlemen, is our equation of a plane in the vector form, where R is a general vector. Nice. The general vector having coordinate xi cap, yj cap plus zk cap. A is the given vector on plane having coordinates as x1 I cap plus y1 z cap plus z1 k cap and is the normal vector. N is the normal vector. So, normal vector to plane. And when it is a normal vector, we are not telling that this is a normal unit vector. This is a normal vector. So, let me consider that dr instead of direction cosines. Ai cap plus bj cap ck cap is equals to 0. Let's find the Cartesian form. How we do it? By simply solving it. So r minus a vector becomes x minus of x1 I cap plus y minus of y1 j cap plus z minus z1 k cap whole dot with normal vector which is ai cap plus z bj cap ck cap is equals to 0. Now dot product we know they simply get multiplied the coefficients. This is the equation of plane in Cartesian form. Very important to understand.
Good evening, sir.
Good evening, Yarini. When did you join?
5:35, 5 minutes back, sir.
Okay. Till now, we have discussed about the planes. First, we discussed that what is a plane. Plane is not airplane's plane, but it's a plane, like just a plane, and it's not bounded by its boundaries. This is just an representation. It is not limited. It's limitless, but it will be only existing in its plane, and the plane can have the inclination, different inclination, and can have different distance from the origin. Then we discussed about the equation of plane in normal form, where a vector from the origin is when it is perpendicular to the plane. Remember, this vector is from the origin and the distance is also. So the equation of plane comes out as d is equals to r vector dot n cap. N cap is the unit normal vector, or should I say normal unit vector to the plane from the origin. It is the equation of plane in Cartesian form. Then we discussed about that it has to be a normal unit vector. And the plane's direction is given by the perpendicular to its plane. So whatever the direction ratios or the direction cosines of perpendicular will be, they will also be the direction ratios or the direction cosine of the plane. Thereafter we solved the question. And then we were discussing about the equation of plane perpendicular to a given vector and passing through a given vector. Simple, it's very simple. The concept that we have used is that the dot product of two perpendicular vectors is zero, and we have applied it using our brain. Let's now solve an example. Give me a moment for that. We have to find the vector and Cartesian equation of plane which passes through the point 5, 2, and minus, and is perpendicular to line with direction ratios 2, 3, and minus. Okay, good question. So what do we have? We have a point on the plane. We have a point on the plane. Sorry, 1 minute. Okay, so what do we have? A point on the plane in the direction ratios of the line, which is perpendicular to it. Okay, so we have the direction ratios of the normal to the plane. Nice. So we have the point as well. So we have everything, right? What was the equation of the plane? That was a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0, where a, b, c were the dr's of the normal, and x1, y1, z1 are the given point, which is there on the plane. Okay, let's substitute 2x minus 5 plus 3 to y minus 2 minus 1 to z minus of minus 4, so plus 4. So this is the equation of plane in Cartesian form. If we have to write in the vector form, then simply r vector minus of a vector. A vector is basically, let me write it first. R vector minus a vector dot product with normal vector is equal to 0. So when we have the dr's of the line which is perpendicular, so we can find out the normal vector from here. We have the dr's, so 2 I cap, 3 j cap, minus of k cap. This is the normal vector. The vector that is passing through the plane is 5 I cap plus 2 j cap minus 4 k cap. Simple. So we'll just substitute here r minus 5 I cap plus 2 j cap. Sorry, plus 2 j cap minus 4 k cap dot with normal vector goes to 0. This is the equation of plane. This is the equation of solved. So now we have to discuss about another topic. We'll find out the equation of plane, which is passing through three non-collinear points. Three non-collinear points. So this time we'll have only this information that we have three non-collinear points existing on the plane. So let's see how we'll find out. Let's begin. First, let me draw the plane. Let's draw a plane. This is this plane. Gigantic. Okay, this is the plane. There are three non-collinear points. So let's consider them three non-collinear points. Okay, so 1 point here, 1 point here, 1 point here. Let's draw their vectors. These are the given non-collinear points. So let's name them. R, let's name them as R, S, and T. Symmetry first, symmetry first, symmetry first. R, S, and T. R has the coordinates x1, y1, and z1. S has the coordinates as x2, y2, and z2. T has the coordinate s3, y3, and z3. These are the coordinates of R, S, and T. Okay. So let's also draw their position vectors. Okay. So let me call this vector as A, this is B vector, this C vector. These are the three vectors, position vectors. Okay. Let me also take a point, a random point on the plane, take general point. So where should I take it? There is space here only. This is a point, random general point on the plane. And whenever we draw the random general point, its position vector is R vector. Okay. Now let me join all these points. PR, SR, ST. ठीक है. Now one thing to understand here, that this is R, A, B, C. These are vectors not lying on the plane. These are vectors coming from the origin. Is my voice audible? Hello,
Yes,
hello.
sir.
Okay. So R, A, B, C, these are the vectors. These are the position vectors coming from the origin to the plane. If I say RS vector, this vector is lying on the plane, the blue ones. If I say RT vector, from R to T, from R to T, from R to T, this vector is lying on the plane. So if I say RP vector, R to P, this vector is also lying on the plane. Now, we know one thing about coplanar vectors, that if we take the prospect 2 and then dot product of the with the remaining, then its product will be 0. Let me tell you the concept. Wait a minute. Yeah, I'm back. So we were discussing about coplanar vectors. Anyways, if we just like leave that concept, let me explain it from the base, from the fundamental. That if I take the cross vector of RS vector and I should say RT vector. If I take the cross product of these two vectors, RS and RT, leave it, RS and RT, then what will be the resultant? The resultant will be perpendicular to both RS and RT as well. Okay. So let me draw that resultant vector with the with this color, red color. So RS, RT will be perpendicular like this, perpendicular to the plane, perpendicular to the plane, somewhat like this. We have to imagine that this vector is perpendicular to the plane, is perpendicular to the plane. This is RS vector cross RT. So RS vector cross RT vector will be perpendicular to the remaining vectors on the plane, right? It will be perpendicular to PR vector as well. Or yes, PR vector as well. If we know that two vectors are perpendicular, then their dot product will be 0. Now, let's substitute. What is PR vector? PR vector is A vector minus R vector. Or should I say, let's take RP vector for a convenience only. So that we have R minus A vector. Just because of the convenience. RP vector will also be perpendicular to the vector that is perpendicular to the plane, right? So there's no problem in that. RP vector, RP vector, RP vector is R minus A vector. Dot RS vector is what? RS is S minus R, which is B vector minus of A vector cross, right? Minus R, C vector minus A vector is equals to 0. And this is the equation of plane. Not that hard to remember, but very easy to understand. Very easy to understand. If we have to find out the Cartesian equation of this plane, then it comes out as, first here discuss, let's what is what. A vector is actually the position vector of R, na? A vector is x1 I cap plus y1 j cap plus z1 k cap. B vector is x2 I cap plus y2 j cap z2 k cap. C vector is the position vector of T, right? Yes. So it is x3 I cap plus y3 j cap plus z3 k cap. So if we substitute A, B, C here, if we substitute A, B, C here, what comes out as the determinant of x minus x1, y minus y1, z minus z1, This time x2 minus x1, y2 minus y1, z2 minus z1. Similarly, x3 minus x1, y3 minus y, z3 minus z1. Its determinant becomes 0 if we expand the vector form. This is not much. What we are doing? We are playing with the vectors and then applying the same concept over and over again. That the dot product of two perpendicular vectors is 0. From there, we are deriving the equation of plane in every situation. And now you will think that, okay, so this is so easy to derive. Why should I remember it? I'll derive it in the exam. But if you do it like that in with every question, you derive, then you find out the formula, then you apply the formula, it will take a lot of time. So that's why you have to remember the formula. And understanding the concept will help you in memorizing the formula. So please read the slide. Let's now discuss about the intercept form. Or the intercept form of the equation of plane passing through three intercepts. Let's draw a plane. The plane is passing through three intercepts. Let me draw a triangle only, na? And understand that it is depicting a plane. This is depicting a plane. Okay. Triangle is depicting a plane. What are the intercepts? The distance of the intercepts from the origin on the x-axis is A. On the y-axis is B. On the z-axis it's C. So simple, it's the equation of the plane in the Cartesian form will be this. Simple. X by A plus y by B plus z by C is equals to 1. This is the equation of plane. Let me ask you a question. If 1, 2, 3 are the intercepts on the x, y, and z axis of the plane, then find the equation of the plane. Can anyone answer? Anyone? There will be x by 1 plus y by 2 plus z by 3 is equals to 1. That will be the equation of plane, simple. Let's now discuss about the equation of plane passing through the intersection of through the intersection of two given planes. Okay. This time we will not require this. This is not required. Let me draw a plane. This is the plane, and there's another plane intersecting. This is another plane intersecting the plane like this. Intersect. Okay. I should draw it differently for so that you will be able to understand. Let me do it using the lines only. Now I'm doing some other plane. This is the intersection of two planes, and the other plane is vertical. Okay, so these are the two planes. Let me call this plane as plane 3, pi 3, this plane as plane 2, and the plane that will be made by the intersection of both of the planes. Or should I say the plane which will be passing through the intersection of both of the planes will be somewhat green. Let me represent it by green. This is plane number 3. Oh, sorry, should I call it plane number 1, which is the plane made by the intersection. This is, let me call this 3 only. These are the first two planes which are given, and this is the third plane which is germinating, which is generated by the intersection. Or should I say, it is passing through the intersection of both of these two planes. Okay, so the given are the two planes, plane 1, equation is r vector dot n1 vector is equals to d1. D1 is the distance, and 1 is the normal unit vector from the origin, the plane. Given pi 2 vector as r vector dot n2 vector equals to d2. So here it says the topic says the pi 3 will be having the equation of r vector dot n1 vector plus lambda of n2 vector is equals to d1 plus, let's write it in the next line, d1 plus lambda into d2. So this will be the equation of the third plane, or the plane that is passing through the intersection of two planes. As we were discussing about the lines per parallel lambda, there will be scalar multiple. This is somewhat on the same lines. Okay, let's find out its Cartesian form as well. So n1 vector is that we are considering it as a1 b1 a1 I cap plus b1 j cap plus c1 k cap. N2 vector will be a2 I cap plus b2 j cap plus c2 k cap. D1 D2 are the D1 D2 only. So the Cartesian form comes out as a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 is equals to 0, where a1 b1 c1, where a1 b1 and c1 are the direction ratios of normal vector 1. A2, B2, C2 and the direction ratios of second normal vector, the normal vector of the second plane. And D1, D2, we know there are the normal distances from the origin to the first plane and to the second. Any doubts?
No, sir.
Okay. Let's discuss a question. We have to find the vector equation of the plane passing through intersection of the planes r dot I cap plus j cap plus k cap is equals to 6 and r dot 2 I cap plus 3j cap minus plus 4k cap is equals to minus of 5 and point 111. So we have to find the vector equation of the plane passing through these two given vectors, and there's point also given to us. Now, don't think that the point is given in the redundancy. It will be of our use, and we'll have to eliminate the lambda from the equation. First, we know the equation of the plane is given by this formula: r vector dot n1 vector plus lambda n2 vector lambda n2 vector is equals to d1 plus lambda of d2. We don't know about the lambda and we don't care about it now. We'll substitute it later. Okay, r vector dot n1, or should we apply the Cartesian form? Let's apply this first. N1, I think we should apply the Cartesian form. That will be better, way better. So let's recall what was the Cartesian formula was. For Cartesian form, A1 x plus B1 y plus C1 z minus of D1 plus lambda into A2x plus B2y plus C2z minus of D2 was equals to 0. Let's bring this to the right hand side. So bringing to the right hand side, this will become negative. From here, we can directly find the lambda. So that's why Cartesian form is better. Even B1, C1 are the direction ratios of the normal vector 1. So the direction ratios here are 1, 1, 1. Direction ratios here are 2, 3, and 4. D1 is 6. D2 is minus of 5. Okay, nice. Let's substitute. A1 x plus y plus z minus 6 is equals to minus of lambda into a2x, that is 2x plus 3y plus 4z minus of minus 5 plus 5 is equals to 0. Now we have to find out the value of lambda. But we don't know about the xyz. But this is actually the equation of plane. When it is the equation of plane, every point on the plane will be satisfying this equation. So if every point on the plane will satisfy this equation of the plane, so the given point that is there on the plane should also satisfy the plane's equation. Na? So let's substitute it for x, y, and z. Okay, doing so, x, y plus z. So 3 minus 6 is equals to minus of lambda into 2x. 2 into 1, 3 into 1, 4 into 1 plus 5. So this has become 2, 3, 5, 5, 4, 9, 9, 5, 14. Minus 3 is equals to minus of lambda into 14. Minus minus cancel. Lambda becomes 3 by 14. If lambda is 3 by 14, we can go back and we can modify the, the equation. Or we can even put it here only because we have to find the vector equation. Na? Lambda is that we have find it out using the Cartesian form. Okay. So r vector into n1 vector, which was I cap plus j cap plus k cap. I cap plus j cap plus k cap plus lambda of n2 vector, right? Plus lambda of n2 vector. Lambda is 3 by 14. So 3 by 14 into 2I cap plus 3j cap plus 4k cap is equals to d1, which is 6 plus lambda, that is 3 by 14. D1 is 6, or D2 is minus of 5. Let's solve it. So R vector dot. So this becomes 3 by 7 plus 1. 3 by 7 plus 1 is 10 by 7. I cap. Okay. I'm doubting my first calculations. So taking, yes, I guess 2 by 3 by 7 plus 1. So 3 by 7 plus 1. Yes, 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 yes. About j cap. So 9 by 14 plus 1. 9 by 14 plus 1. 14. So 14 is the LCM. And let's do one thing. Let's take the 14 as LCM here. Because on the right hand side, we'll also take the 14 as LCM. So 3 to the 6. 6 and 14 will become 20i. 14 j cap plus 9 j cap becomes 23 j cap. Okay. Now 14 k cap plus 12 k cap will make it 26 k cap. Simplified. Taking 14 LCM, 14 6 are 84 minus 3 5 is 15. 14 14 cancels. This becomes R vector dot 20 I cap plus 23 j cap plus 26 k cap is equals to 84 minus 15, that is 70 69. And this is our answer. A little longer, I know, but this was the example of elementary book. So if it were to ask in NDA, they'll only ask for the lambda or something other, which is a shorter question. Is this question clear now?
Yes, sir.
Now the next concept. Here we have to find out the equation of plane when two lines are given. Let's take a plane. Good plane. Okay. Let's take two lines on this. So there is line one. Let me draw the line with pink. So there are two lines. Line one and line two. L1, L2. These are the lines. So when lines are given to us, what is given with them? When lines are given to us, what is given is their direction ratios of the line, right? So let's consider that their vector do we have? We have the vector of the given lines. L1 line, its vector is R vector is equals to E1 vector plus lambda into B1 vector. For line 2, R remains same. R vector is equals to E2 vector lambda of B2 vector. We remember a vector B1 and vector B2 will give us the direction for the lines in vector E1 and E2. These are the vectors which they will be existing on the lines. So if let's say let's take this point on this line and this point on this line. So if I take a vector, I'm actually drawing the E1 vector, the E2 vector. So I use this color and E2 vector. So this is E1 vector, this is E2 vector. These 2 points are existing on these lines. Okay, good enough. Now, we also know that B1 vector will be somewhat in the direction of L1 or parallel to the L1. B2 vector will also be somewhat parallel to the L2. Let's consider L1, B1 vector and B2 vector. B1 vector is E1 I cap plus B1 J cap plus C1 K cap. And B2 vector as A2 I cap plus B2 J cap plus C2 K cap. So this is B1 and B2 vector. Okay. Now, let me call these points as A and B. A1, A2 vector we have. So let's find out the AB vector now. A to B vector is this. So AB vector will be simply B vector minus A. B vector is simply A2 vector minus A1 vector. And also, let's find out a perpendicular vector to the plane. How we will do so? That these two vectors, L1 vector, in the L1 direction, there will be a B1 vector, and in L2 direction, there will be another B2 vector. If I take the cross of both of these vectors, see, understand clearly, B2 vector and B1 vector. If I take a cross between both of these two vectors, this is actually this is B2 vector, this is B1 vector. If I take a cross between them, so the resultant vector will be perpendicular to the plane. The resultant vector will be perpendicular to the plane. B1 cross B2. So this is the normal vector to the plane. And AB vector is lying on the plane. See, A1, A2 vector are the position vectors. They are coming from the origin to the 2 points of the plane. But the EB vector is the vector coming from a point to the other point on the plane. So the vector is completely lying on the plane. If the vector is lying on the plane, we know the plane is perpendicular to B1 vector cross B2 vector. This is perpendicular to the plane. And we know on plane there lies an AB vector which should also be the perpendicular to B1 cross B2. And if that is so, same concept, yeah, same concept. AB vector will be giving us dot product of 0 with the perpendicular vector. AB vector is what? A2 minus A1. A2 vector minus A1 vector dot B1 vector cross B2 vector. 0. This is the equation of line. Simple, simple. This is the equation of the plane. The vector. Remember, even B1 C1 or B1 vector is, see, let's explain whatever E2 is. E2 vector uh, is the vector position vector of the point that is there on the line 2. So it was x2 I cap plus y2 z cap plus z2 k cap. E1 vector will be x1 I cap plus y1 z cap plus z1 k cap. B1 vector direction ratios of line 1. So direction ratios are given in the form of A1, B1, C1. We have discussed about them. B2 vector. If the line is given in the format of Cartesian form, and line 1 will be x minus x1 upon A1, y minus y1 upon B1, z minus z1 upon C1. The line 2 will be x minus x2 upon A2, y minus y2 upon B2, z minus z2 upon C2. This is the line 2 Cartesian equation. So if we are discussing about the Cartesian equation of line, let's also discuss about the Cartesian equation for the equation of plane. That will become x2 minus x1, y2 minus y1, z2 minus z1 divided by a1, b1, c1, a2, b2, c2. This is the equation of plane, the Cartesian form. Now, from this topic only, we derive the condition for coplanarity of two lines. If the above condition, if the equation these conditions are satisfied, then lines are coplanar. Let me write them again for you. Condition in the Cartesian form is this. Actually, the equation only are. I should stop saying yaar. This is the equation of in Cartesian form, or we are discussing about the vector form, then this. This becomes the condition for coplanarity of two lines. Understood? Like you will not be able to memorize, but is the process clear to you? Yes or no? Yes. Okay then. Let's now discuss about the angle between two planes. There are two planes. Let me draw them. This is plane number one. This is plane number two. Let me draw it like this. This is plane number. So the plane number one's normal vector is this. And the normal vector of plane 2 is somewhat this. Okay. When we have to find out the angle between two planes, actually what we do is that we find out the angle between the direction of both of those two planes. So when we are talking about the direction of a plane, what we actually talk about is the direction of the normal vector to the plane. So here is n1 vector, here is n2 vector. We'll simply find out the angle between these two, and the angle between the normal vector of the planes will be the angle between the planes. Okay. So it is simply angle between normals of planes. Okay. How do we find out the angle between two vectors? Very easy. Cos theta n1 vector dot n2 vector divided by the magnitude of n1 vector and the magnitude of n2 vector. Simple. This is using the vector form. We have to write the Cartesian form where n1 vector is E1 I cap plus B2, sorry, E1, E1 I cap plus B1 J cap plus C1 K cap. N2 vector is A2 I cap plus B2 J cap plus C2 K cap. These are the two normal vectors. So here cos theta will be simple dot product A1 A2 plus B1 B2 C1 C2 divided by square root of A1 whole square plus B1 whole square plus C1 whole square A2 whole square plus B2 whole square plus C2 whole square and whole magnitude, whole modulus. So this is the formula of cos theta. When we are discussing about Cartesian forms, now comes some cases, important cases. Two planes will be perpendicular if their normals are perpendicular. And if their normals are perpendicular, the dot product will be 0. If I have to write it in the Cartesian form, then A1, A2, B1, B2, C1, C2 becomes 0. Case number 2, if the planes are parallel or are having the same direction, so their normal vectors will also be parallel. If normal vectors are parallel, we know n1 is equals to lambda of n2 means their direction ratios will be proportional, equal to some scalar quantity. These are two cases. Important. And even if we have to find out the angle between the line and the plane, then also we take the normal of the plane and the line's line vector. Then we find out the. That's simple, very simple. Okay. Now let's talk about the distance between the plane and the origin and another point. Distance between the plane and another point. Distance of a point from a plane. So we know we find the shortest distance. So if we have to find out the shortest distance, that will be the perpendicular distance. First, let's draw the plane. And then let's consider this is a plane. And there's a point for which we have to find out the distance. Point is x1. Let's take this point as x, y, z only. X, y, and z. And if we have to find out the distance between the plane and the point, we'll find out the perpendicular distance. Okay, so perpendicular will be somewhat here, I guess. Assume that this is the perpendicular. Let's call this distance as d. And the position vector of point P as a vector. Okay, so the distance will be given by direct formula. Modulus of a vector dot n vector minus of t divided by the modulus of n vector. This is the formula for finding out the distance, where a is the position vector of P, that is xi cap plus yj cap plus then k cap. And n vector is the normal vector of this plane. Like the equation of the plane is given like this. Na? So this n vector is the n vector. If we have to find out the perpendicular distance between a plane and the between the plane and the origin, then simple, the position vector of the point being origin will be zero vector. Na? So if zero vector gets multiplied to the normal vector, it becomes zero only. So when finding distance of plane from origin, then a vector of the point becomes zero vector. Na? So d becomes minus of d and vector. Small s. And if n is the given normal unit vector, then simply the d, whichever it is given, it will be the It will be the direction from the origin. Is this concept clear? Say yes or no. Hmm. Okay. Next topic is to discuss the angle between a plane and a line. Let me draw the plane. So this is the plane. Okay. And this is our line. This is our line. Let me draw the perpendicular with the, okay, this is the perpendicular of the plane. Okay, so this is n vector, and this is actually the line. So the direction of this line will be given by b vector. So let's say equation is a plus lambda b. B is actually the vector that will give us the direction. Let's call this angle as theta, the angle between the normal of the plane and the line. And the angle between the plane and the line will be 90 minus of theta, which we are calling as phi. And actually, we have to find the phi, not the theta this time. Why not the theta? Because we are literally talking about the plane and the line, which can be simply find it out. That is why. So the angle between the plane and the line is 90 minus theta. First, let's find out the cos theta. Cos theta will be simply r by n vector dot b vector divided by n vector's magnitude to b vector's magnitude, all this thing. But when we replace theta with, when we have to find out, when we replace theta with in terms of phi, so from here we can write 90 minus phi. From here, what we can write is 90 minus of phi is theta. So theta can be written as cos of 90 minus phi. We know cos of 90 minus theta is sine theta. Cos 90 minus a, sine a. So this becomes sine of phi is equals to n vector dot b vector divided by n vector's magnitude and b vector's magnitude. This is the formula, simple. So this time things change. If a line and a plane are perpendicular, if a line and plane are perpendicular, if line and plane are perpendicular, so the dot product becomes 0 and vector dot b vector becomes 0. B is having the directional ratios, simply a1 b2 plus b1 b2 c1 c2, where a1 b1 c1 are the directional ratios, of plane, of normal of the plane, and a2 b2 c2 are the direction ratios of line. If line is parallel to the plane, if line, oh, sorry, I have written it otherwise. This was the case of, parallel only. Line was parallel, then this happens. Because if line is parallel to the plane, means the plane's normal will be perpendicular to the line. That's why this is happening. If line is perpendicular to the plane, so n vector will be proportional to b vector, and a1, a2, the dr's will be proportional to some scalar quantity. Any doubts?
Yes, sir.
Okay, so let's discuss an example. Now we have finished all the topics of this chapter. All the topics of this chapter. Yes, it's a little longer. It will fill your multiple pages of your notebook, but it's not hard. It's not hard. It's just that once you understand the topics, now it will be very easy for you. See, after like 1 hour, 50 minutes of class, my head is aching. So yes, I definitely agree that the topics are little like longer, but once you understand them, it's once you understand the topics, the concepts, the formula become easier to memorize, and that's only what you want. Only formulas. So in this question, we have to find out the angle between the line and plane. Line is x plus 1 divided by 2 is equals to y by 3 is equals to z minus 3 by 6. And the plane 2x plus 2y minus 11z is equals to 3. So the dr is simply what we care about is the dr only, the direction. So direction for line, dr's of line are 2, 3, and 6. The dr's of plane are 10, 2, and minus 11. Let's find out the sine of pi. 2 into 10, 26 minus 66 divided by square of 2, 4, square of 3, 9, square of 6, 36, square of 10, 100, square of 2, 4, square of minus 11 is 121. 26 minus 66 becomes minus of 40 divided by 36 plus 13 becomes 49. Square root of 49 is 7. And this becomes 104. 104, 121, 5, 2, 225 square root is 15. Its whole modulus will make it positive 40 upon 7 into 15. So 5 by 40 by 8 is 40 by 5 is 8. 15 by 5 is 3. So this comes out as 8 by 21, which is actually sine phi. So the angle between the line and the plane is sine inverse of 8 by 20, which is our answer. Any doubts?
No, sir.
Okay. Okay, let's solve some questions. So, in each of the following cases, find direction cosine of normal to the plane and also distance of plane from origin. The first part is given as z is equals to 2. So this is the equation of plane that is given. Okay, if this is the equation of plane, then we can write it as 0x. Wait, give me a minute. Sorry. Yes. So we can write it as 0x plus 0y plus 1z is equals to 2. So the dr of the plane, actually dr's of the normal of the plane, they're the same thing. 0, 0, and 1. Let's make sure that these are the direction cosines. So for that, we'll find out the magnitude. Magnitude is 0 square plus 0 square plus 1. So that is 1. So basically, these are the direction cosines also. So if these are the direction cosines, then we know r vector dot n cap. N cap is 0i plus 0j plus 0k. So actually, it's k cap only. It's equals to 2. When this is a unit vector, then this distance is the distance from the origin itself. So this 2 units is the distance from the origin. That is our answer. 2 units and the direction cosines are these 0, 0, and 1. Next question. The equation of plane is x plus y plus z is equals to 1. So the dr of the plane are 1, 1, 1. Okay. So the dr of the plane are 1, 1, 1. The d distance is 1 given. Now let's find out the direction cosines by dividing them. Square root of 1 square plus 1 square plus 1 square. 1, 1, 1. So this becomes actually square root of 1 square plus 1 square plus the magnitude is 3, square root of 3. So direction cosine becomes 1 by root 3, 1 by root 3, 1 by root 3. Is this clear? Is this clear? How have I find out the direction cosines?
Uh,
Yes or no?
yes, sir.
Should I repeat? I can repeat if there is any doubt.
No, sir. Clear, sir.
Okay. If these are the direction cosines, so this is what we have to find out. Direction from the origin, we know the formula. When we have to find out the direction from the origin, minus of d divided by the magnitude of the given normal vector or the magnitude of given dr's. Okay. So what is the d given? That is 1. So minus will make it a positive divided by the magnitude of n, which is root 3. So 1 by root 3 is the answer for the distance. Clear?
Yes, sir.
Let's do a full question also, then we'll conclude the class. Is there any class after this class?
No, sir.
This is the question. So what is given to us? Given is that the distance from the origin is given. Distance from the origin is given as 7 units. And the vector normal to the plane is also given. So everything is given to us actually. We have to just find out the vector equation for this. So D is given and normal vector is given. Normal vector is 3i cap plus 5j cap minus 6k cap. We know the equation r dot n cap is equals to d, where d is the distance from the plane from the origin and n cap is the normal unit vector to the plane. But we have the normal vector, so let's find out the normal unit vector by dividing it by the magnitude of the vector. So let's find out the magnitude of the vector, which is 3 square 9, 5 square 25, 6 square 36. So this becomes 34 plus 36, 70. Square root of 70. So square root of 70 into 3i plus 5j minus 6k cap. So r vector dot 3i cap plus 5j cap minus 6k cap is equals to d 7 into root of 70. We have brought the root of 70 to the right hand side. This is our answer, equation of plane. Any doubts? कोई शक? Yes or no?
Yes, sir.
कोई शक? Any doubts? Do you have any doubt regarding?
No, means I'm clear, so no doubt.
Okay, so have you seen, have you heard the dialogue of Amitabh Bachchan's movie, Koi Shak?
Koi Shak from which movie?
I don't know the name, but I just remember the dialogue. In that movie, Amitabh Bachchan says Koi Shak. Anyways, shall we conclude the class?
Yes, sir.
Yes.
Okay. Thank you.
Thank
Jai Hind.
you, Jai Hind.
Thank you, sir.